My name is Yang Zhou. I'm currently a senior lecturer at the University of Auckland from New Zealand, quite far from here, I know. Today, actually, I just want to present a paper titled Enhancing the UAV Efficiency in Bridge Inspection through BIM-based flight planning and image quality assurance. So first of all, I would like to introduce the team. So the first author is one of my PhD students. So he's now starting a postdoc fellow in Hong Kong. So we also got Enrique and James. They are the co-supervisor of the PhD student. So today I would like to divide the talk into 4 parts. By introduction, methodology, experimental results, and also an outlook for our future research. So why we focus on using drones? Because in the world we know that globally our infrastructure systems is deteriorating and also aging. So just put some extreme scenarios. For example, if your bridges, large span bridges, and other like towers, if you do not just maintain them well, also you do not understand the health condition of those facilities well. So you probably will see some very extreme scenarios, such as, for example, the full failure or partial failure of those structures. So one of the trendy topics, I think, since 2015. So if you can see some of those top journals, that there are lots of work focusing on using the flying robot, so which is the drones for inspecting those bridge facilities and also the buildings. So comparing the traditional inspection approach for bridges, for example, using the aerial systems, also the roping systems, which is very time-consuming, also costly, and you also need to most likely control your traffic or close the traffic. So we don't want that happen. So we now can just employ the drones. So currently there are 2 ways to deploy the camera-based drone for inspection. The first one is that you can still take individual images and then do the analysis, understand if there's any like defects like cracks from the individual image. So the second way is sounds a little bit premier. So we use the photogrammetric 3D reconstruction. So which means that you fly the UAV and then take a series of images and then use the images to reconstruct the 3D model of the bridge in point cloud. By using this way, you can get a more holistic view of the bridge. There is another thing to mention, that why we do not use LiDAR here, because it's quite difficult to detect the cracks using LiDAR. So by using photogrammetry 3D reconstruction, so we can get both the images and then the 3D point cloud, so which is perfect for inspection purpose. But when we are using the camera-equipped UAV, so we also observe lots of issues, because the quality of the generated model is very critical for our inspection. If the model is in low quality, so the results are not reliable. So some of the issues we observed, including, for example, blurriness and also exposure, and also the coverage. Sometimes you cannot just coverage the whole, all the aspects of the bridge, and also the resolution sometimes is not good. So existing solutions, including, for example, deploying those computer vision or machine learning technologies to enhance or correct the issues for images. And also, you can manually check those images and redo the flight. So there's still a gap that we found. There's no real-time inspection approach that can check the images in real time. So in this work, actually we proposed a framework. It consists of 2 phases. The first one is that we're still using BIM to drive the um, the flat planning. We tell the drone where roughly the bridge is, and then it can generate an ideal flat path for our inspection. And secondly, we deploy the drones, and then we use the incremental, sorry, so we use the 3D reconstruction technologies to generate the 3D point cloud for the bridges by step. And then we run the image blurriness and also exposure check, coverage check, and also spatial resolution check. And then further project, and then those results into color-coded information and mapped into the 3D model. So this is a further illustration of the whole framework. You can see that we actually developed a workflow to determine. So, for example, initially those grids, voxels, they are in gray color, but after each checking, so we project those pixel information in different colors back to each voxel. So that's why in the next slide, in the next slide, you will see that to evaluate our proposed framework. So we have run two types of the validation. So the first one is that we run a simulation and build different types of the bridges in the simulation and evaluate whether the proposed framework can be better than our manual way. So you can see that according from the results, we can conclude that from the simulation results, we can reach over 50% improvement than the manual way. So, but we also done some another evaluation, which is to use the real bridges. So this is a typical reinforced girder bridge in New Zealand. Used to be part of the highway system, but it's abandoned. So we just pick up the two middle spans and also the wall pier for experiment. So you can see that. So these are our results. You can see the blurriness. We can use you see using the different colors, and this is the scale. So we can see easily identify those problems, those quality issues we have captured using the UAV. Also, the exposure density from this the images below here. So you can see you can easily find those problems like shadow or bright background, desert night, and also too much reflection from here. So these are the example results. So we compared by using our proposed framework and also the photogrammetry 3D reconstruction results. So you can see that because we use this kind of octomap to generate the color-coded results. So it's very easy for us to find those issues, for example, missing areas, and also overexposure or underexposure issues, and also some empty areas, possibly because we failed to capture enough images that have the overlapping. So by doing this, we hope that we can improve the inspection efficiency. So when we actually deploying the drones for the inspection, so we can check those image qualities in real time, and then if there's any images not in good quality, so we can actually correct those issues in real time, maybe just by optimizing the drone flights and then recollect the image again. So in conclusion, so we found the BIM-based flat planning definitely can facilitate the quality for the data capture. And also the image quality assurance framework offers a rapid and also a comprehensive assessment for the UAV captured bridge images. Also with the color-coded results, we can ensure high quality of the UAV capture results. And also, Feng has open sourced all the codes he has developed for the project. So this just shows our roadmap, and then I think we are here now, but still in the future, we are considering how, for example, to remove the BIM part and then to make the whole process more autonomous, more automated, and also in the meantime, just making sure the data is in good quality. All right, thank you so much, everyone.